Topic: Drone flight subtopics, introductions to drones, drone components, aerodynamics and flight mechanics, regulations and safety. Introduction to drones, types of drones, fixed-wing drone. A fixed-wing drone is a drone designed to have one rigid wing and works like an airplane. What differentiates fixed-wing drones from other types is that they cannot stay in one place with vertical lift rotors, but instead glide on a set path as long as their energy permits. This means they can be far more efficient compared to the two other main categories of drones. Single-rotor drone. Single-rotor drones are very strong and look similar in structure and design to actual helicopters. They have one big rotor, like a big spinning wing, and a small-sized rotor on the tail for direction and stability. Multi-rotor drone. It is preferred by hobbyists and professionals because of its small size. They carry several rotors on their body and can be further classified based on the number of rotors in them. UAVs can also be classified by range and size. Range: close range. Most close-range drones usually have a range of around 4 to 5 kilometers, 3 miles, and can stay in the air an average of 20 to 30 minutes. Short range. Most short-range UAVs can be controlled from up to 30 miles away from their users and can stay in the air for an average of 1 hour to 6 hours. Medium range. Most medium-range UAVs can be controlled from up to 90 miles away and can stay in the air for up to 12 hours. Size: nano, about the size of an insect. This is a very small UAV, larger than an insect, but still quite small. This is the size of most consumer UAVs. Medium, smaller than light aircraft and usually requires 2 people to carry them. Large, the size of a small aircraft, usually used in military or surveillance situations. Drone component, drone frame or chassis. The frame or chassis is the body of the drone and is the component that serves the function of holding all the parts together. Therefore, each of the parts of a drone are attached to it according to a configuration that allows the UAV to have an excellent aerodynamic performance. It functions as the structure of a drone that allows all the components to be assembled and is usually the one that defines the size of the drone. Motors. Another element of a drone that is of great importance is the motors. They are the fundamental parts that help keep the drone up and running. The motors of a drone are located at the ends of each of the arms of the frame and are responsible for generating the propulsive force for the drone to soar. Drone propellers. The motors do not have the capacity to lift the drone on their own, as they must be connected to propellers that are in charge of rotating to provide lift to the drone. Most drones have a pair of standard propellers, which rotate counterclockwise, and a pair of reverse propellers. This provides greater stability during flight. Battery. The motors, as well as the other electrical and electronic components of the drone, need power to operate, which they get from a battery that is located in the frame. There are various types of batteries for drones, although the most common are LiPo batteries, which offer great performance and autonomy in flight. Camera. The camera is one of the most important parts of a drone when used for aerial photography or drone filming. Although not all drones have this element, it is one of the most common accessories. Flight controller board. One of the most important parts of a drone is the controller board, not to be confused with the identification plates or number plates of a drone, which acts as the brain of the UAV. This drone flight controller is responsible for receiving and recording all the information coming from the controller, the geolocation system, the sensors and other interconnected elements, while sending the necessary signals to control the drone's movements during flight. Other components of great relevance to the control of the drone, such as the compass, gyroscope and sensors, are usually located on this board. Sensors. Although not all drones have the same components, they usually have a number of sensors that are important for the drone's performance. These include speed sensor. This allows the speed at which the drone is moving to be determined by interpreting the air pressure impacting the device. Height and altitude sensors. These sensors use pressure variation to detect how high the drone is flying in relation to the ground and its position in relation to sea level. Position sensors. Position sensors are used to determine the location of drones accurately and instantly. These sensors work with satellite-based systems such as GPS, Global Positioning System, or other global positioning systems such as GLONASS and Galileo to determine the exact location of the drone. These sensors enable drones to navigate during flight, avoid obstacles, and follow the specified route. Thanks to the real-time data flow, drone operators can instantly see the location of the drone and direct it when necessary. GPS, which stands for Global Positioning System, is a satellite-based navigation system that provides location and time information to a GPS receiver anywhere on Earth. Developed by the United States Department of Defense, GPS uses a network of satellites to provide accurate positioning data for various applications, including drone navigation. When it comes to drone technology, GPS plays a crucial role in enabling features such as autonomous flight, return-to-home functions, and waypoint navigation. GLONASS. By using signals from GLONASS satellites in addition to GPS satellites, a drone can enhance its positioning capabilities and maintain a stable flight path. GLONASS is particularly useful in areas where GPS signals may be obstructed or weakened, such as urban environments, forests, or mountainous terrain. Having access to both GPS and GLONASS signals can significantly improve a drone's performance, especially when it comes to precise navigation, flight stabilization, and autonomous flight modes. Gimbal. This part of the drone is essential for stabilizing the camera during drone flight. It is a complement that is placed between the frame and the camera to prevent the vibrations of the motors from affecting the quality of the images captured with the drone. Variable speed drives or speed controllers, also known as ESC, electronic speed controllers. These components help to improve the flight experience as they allow you to vary the speed and direction in which the drone moves in a simple way. Drone control station. The control station usually consists of 3 elements or controls of a drone, including the radio transmitter and receiver, the data management components, and the remote control. The remote control is one of the components that you will need to familiarize yourself with when you are learning how to fly a drone for the first time, as it will be the one that allows you to control the drone precisely. Landing gear. This is one of the most important parts to ensure the integrity of the drone when it comes into contact with the ground. The landing gear is a structure that goes on the bottom of the drone, which allows you to maintain an adequate distance between the body of the drone and the ground. Aerodynamics and flight mechanics. The subject of fluid dynamics. A sufficient amount of upward force is required to lift the vehicle against gravity, which is named lift. A force created to move the vehicle or body in motion is called thrust. These forces can be studied using the kinematic laws of fluid flows. The flow pattern around the cross-section of the aerofoil or propeller is shown below. High fluid pressure at the bottom and low pressure at the top of the propeller cause an upward force which is called a lift. Based on the principle of conservation of energy in fluid flow, Bernoulli's principle, the sum of all forms of energy in a fluid is constant along the streamline. When air flows over an aerofoil or wing, its velocity increases at the top portion, but the pressure of air decreases. In contrast, the air velocity decreases, and pressure increases at the bottom side of the blade. The next pressure difference across the aerofoil results in an upward force which is called a lift. Major forces acting on a drone weight. Due to the mass of the drone, the body mass force always acts in the direction of gravity. The higher the weight of the drone, the more power is required to lift and move the drone. Weight of drone equals mass of drone times acceleration due to gravity. Lift. The vertical force acting on the drone is called the lift. This force is due to pressure differences across the drone in the vertical direction. Hence, the speed, size, and shape of the propeller blade decide the amount of lift force. Lift is essential to lift the body against gravity. To create this force, all 4 propellers run at high speed to lift the drone. Drag, the force acting on the drone in the opposite direction of motion due to air resistance, is called drag. This may be because of pressure difference and viscosity of air. To reduce the drag, the aerodynamic shape of the drone is selected. Thrust. The force acting on the drone in the direction of motion is called thrust. However, for drone dynamics, it is normal to the rotor plane. During hovering, the thrust is purely vertical. If thrust is inclined, then the drone will tilt forward or backward. This force is essential to move the drone in the desired direction at equal speed. To get the desired motion, two propellers have been given high speed. Working of modern drones' aerodynamics and lift rotary wing drones, quadcopters. Most common drones, like quadcopters, use multiple rotors to generate lift. Each rotor consists of a motor and a propeller. When the propellers spin, they create a downward thrust by pushing air downwards, which in turn generates an upward lift force, allowing the drone to hover, ascend, or descend. Fixed-wing drones. These drones operate more like traditional airplanes, using fixed wings to generate lift. They require forward motion provided by a propeller or jet engine to create airflow over the wings and generate lift. Propulsion system motors. Electric motors are typically used to spin the propellers. These motors are powered by batteries, propellers. The design and angle of the propellers are crucial for generating the necessary thrust to lift the drone. Control system, flight controller. The central processing unit of the drone that takes inputs from sensors and the pilot's commands to control the motors and maintain stable flight. Sensors. Drones are equipped with various sensors, including gyroscopes, accelerometers, magnetometers, GPS, barometers, and sometimes cameras or ultrasonic sensors. These sensors provide data about the drone's orientation, speed, altitude, and position. Electronic speed controllers, ESCs. These regulate the speed of the motors based on commands from the flight controller. Communication system remote control. Drones are typically controlled via a remote control or a smartphone app, which communicates with the drone via radio waves, often 2.4 GHz or 5.8 GHz frequencies. Telemetry. Some drones send back real-time data to the pilot, including battery status, GPS location, and camera feed. Power system. Battery. Drones use rechargeable lithium polymer (LiPo) batteries that provide the necessary power for the motors, sensors, and other electronic components. Navigation and positioning GPS. Many drones use GPS to navigate and maintain their position. GPS allows for precise control over the drone's location and enables features like waypoint navigation and return-to-home functions. Obstacle detection and avoidance. Advanced drones are equipped with sensors that detect obstacles in their path and adjust their flight path to avoid collisions. Stabilization and maneuvering. Stabilization algorithms. The flight controller uses algorithms to interpret sensor data and make rapid adjustments to the motors, ensuring stable flight. This includes maintaining balance, attitude control, and controlling yaw, pitch, and roll. Maneuvering. By varying the speed of individual motors, the drone can move in different directions, rotate, and perform complex maneuvers. Payload cameras and sensors. Many drones are equipped with cameras or other sensors for various applications, such as photography, videography, surveying, and environmental monitoring. Delivery mechanisms. In delivery drones, mechanisms are included to carry and release packages. Sample drone circuit diagram. Regulations and safety. The International Civil Aviation Organization, ICAO, is a key body that establishes global standards for drone operations, ensuring safety and efficiency in international airspace. In addition, the European Union Aviation Safety Agency, EASA, formulates regulations that apply across its member states, advocating for uniformity and safety in drone usage. Similarly, the Federal Aviation Administration, FAA, in the United States acts as a regulatory authority, setting comprehensive guidelines that influence both domestic and international drone policies. National aviation authorities, such as Transport Canada and the Civil Aviation Safety Authority, CASA, in Australia, also contribute to the framework of international drone regulations. These bodies not only implement regulations, but also collaborate with international organizations to harmonize efforts towards safer drone operations globally. Essential requirements for operators. Drone operators are subject to a variety of basic requirements to ensure safe and legal operations. Registration of drones is often mandatory to ensure accountability and track ownership. Pilot certification is another critical requirement for drone operators. Operational limitations determine where and how drones can be flown. These include restrictions on flying above certain altitudes, near airports, or in densely populated areas. UAV registration is the official recognition of an unmanned aerial vehicle, UAV, in the airspace. It facilitates the traceability of UAV operations. In various jurisdictions, the registration process typically requires the following details: owner details, make, model, and serial number of the UAV, intended use of the UAV. Most countries require UAVs over a certain weight threshold, typically starting at 250 grams, to be registered. Pilot certification. Our pilot certification is a formal certification that an individual has the skills and knowledge required to operate a drone safely and efficiently. This certification ensures that drone operators understand the legal frameworks, safety protocols, and technical proficiencies required for compliant flight operations. Operational limitations. Operational limitations define specific restrictions within which drone operations must occur in order to ensure compliance with international drone regulations. These restrictions cover a variety of aspects, including maximum altitude, distance from the operator, and restricted airspace areas. Complying with such restrictions is critical to maintaining safe airspace and minimizing risks to other aircraft and individuals. Additionally, operators are often required to maintain visual line of sight with their drones, limiting the operational distance to ensure rapid response capabilities in emergency situations. Privacy and data protection in UAV regulations. Various countries have implemented specific measures to mitigate privacy risks. For example, the European Union's General Data Protection Regulation, GDPR, provides strict guidelines on data processing affecting UAV operators who collect personal data. In contrast, the United States has a more fragmented approach, with individual states enacting their own privacy laws. Safety standards and compliance. Safety standards for drone operations are established to reduce the risks associated with flying drones. International drone regulations prioritize a framework designed to ensure drones can be operated safely in shared airspace, balancing innovation and public safety. Ensuring compliance with safety standards extends to regular inspections and maintenance of drone equipment. Remote identification technologies. Remote identification technologies serve as a foundational framework that enables drones to be tracked and identified in real time. The key functions of remote identification technologies include real-time tracking, provides authorities with the ability to dynamically track drone locations. Operator information increases accountability by sharing critical data about the drone operator. Flight path data records the trajectory of drone flights and assists in incident investigations.